So we're going to start our next section, which is 4.5. It's about limits at infinity. And so our goal in this section is we want to discuss the end behavior of a function on an infinite interval. So we're going to start by looking at an example. Let's say I look at the function 3x squared over x squared plus 1. So one thing you could do is you could graph this function, have your calculator or program graph this function, and if you graph this, you'll see that the graph looks something like this. And it should look symmetric here. So as x increases without bound, so as x gets bigger, I'm going to look at my y values on my graph, and they're increasing up, and it looks like they're increasing up to 3. So it looks like f of x appears to approach 3 as x increases without bound. And also if I look as x decreases without bound, if I go into the negatives, again my y values look like they go up and they get closer to 3. So f of x appears to approach 3 as x decreases without bound. We could also see this using a table if we wanted to. So here's x, here's f of x. These are like the tables we looked at before. So if I plug in 0 into my function, I get 0. If I plug in 1, 1.5. If I plug in 10, 2.9703. If I plug in 100, and again, just a reminder, our function is 3x squared over x squared plus 1. 100, it's 2.997. And now let's decrease from 0. So I plug in -1, 1.5. If I plug in -10, 2.9703. -100. And if I plug in -100, it's going to be 2.997. So if I look as x gets larger here, as x gets larger, I look at my y values and they're appearing to get closer and closer to 3. So as x goes to infinity, as x gets really, really large, it's like f of x approaches 3. If I look as x decreases without bound, I could say x goes to -infinity. My y values, again, they're the same y values I had before. So it looks like f of x approaches 3. So in this case, we would write the limit as x goes to -infinity is 3, and the limit as x approaches infinity is 3. So we would write these two things here. So now that I've computed these limits, we can talk about this definition. Say the line y equals L is a horizontal asymptote of the graph of f when the limit as x approaches negative infinity of f of x is L, or the limit as x approaches infinity of f of x is L. So if we look back at our previous example, y equals 3 is a horizontal asymptote of the function. Our function there was 3x squared over x squared plus 1.